Hi, welcome to the screencast of 1.3, Solving Equations. So here we're going to be translating vertical expressions and algebraic expressions. Literally means we're going from words to numbers and numbers to words. So let's try this first one. 5 times 6 equals 30. So I can do 5 times 6 equals 30. So the times just means we're going to be multiplying. The difference of a number and 3 equals 6. So here the equals means the equal sign, 6. So the difference of a number and 3. So difference means subtract. So a number n and 3 is equal to 6. Down here we can try to translate the expression into words. So we could say 3 plus a number equals 12. This last one, x squared minus 3 equals 13. So we could say a number squared. So that takes into account that x is squared. Minus 3 equals 13. Another way we could write that is the difference of a number squared and 3 is 13. Okay, let's go to example 1. Translate the verbal expression into an algebraic expression. 3 times the difference of a number and 8. 3 times, the difference of a number and 8. The difference of a number and 8. So you take a number minus 8. So I'm just using n for the variable. And I'm multiplying all that by 3. The next one is the cube of a number increased by 4 times the same number. So the cube of a number, so I'll just do x to the third, increased by 4 times the same number. So increase is added 4 times that same number. So 4 times that same number is 4x. Increased is the add, and then cube of a number, x cubed. Translate into a verbal expression. So we could say the cube of a number increased by 4 times that same number. So this is literally what we wrote above. The cube of a number, we could say added to the product of 4 and that same number. Alright, translating equations, write a verbal sentence to represent the equation. 2 times the number is equal to the difference of that same number squared and 4. So that works. Alright, properties of equalities used to solve equations. So reflexive means a is equal to a, b plus 12 is equal to b plus 12. So a number is itself, right? 1 equals 1, fish equals fish, x equals x, 7 equals 7. Literally, you have the same thing on both sides. Symmetric means a is equal to b, then b is equal to a. You're literally flipping it. So if x equals 7, you're flipping you're switching the sides. 7 is equal to x. So you could say if 18 is equal to negative 2n plus 4, then negative 2n plus 4 has to equal 18. It's just flipping. Doesn't matter which side of the equal sign the two terms or expressions are on. Transitive for all numbers a, b, and c. If a is equal to b and b is equal to c, then you can say a is equal to c. So if x is equal to 7 and x is equal to y, so let's see, we have x equals 7, x equals y. Well, you can set these two equal to each other and we can say 7 is equal to y. The last one is substitution. If two terms expressions are equal, they can be substituted in for each other. So up here, if a is equal to b, a can be replaced by b. So up here, we said that 6 plus 1 times x is equal to 21. Well, what we can do is say, well, I know 6 plus 1 is 7, so I can just sub that in, and then I have the same thing. So I could say 5x is equal to 10, and I know x is equal to 2, so you just plug that right in to x, and then that makes it true. Alright, name the property illustrated with the following statement. If negative 11a plus 2 is equal to negative 3a, then the opposite is true. So it's literally symmetric. It's showing you what's on the left side is equal to the right side. Symmetric, if x equals y and y equals z, then z equals x, and then x equals z. So this is the transitive. So it's almost like you're translating, going from one to the other. So we knew what x is equal to, we know what z is equal to, well secretly they're the same thing, so then you can set them equal to each other. And then 12 is equal to 12, well that's reflexive, anything is equal to itself. Reflexive. Alright, additional properties of equalities. So for any real numbers, if a is equal to b, then a plus c is equal to b plus c. So literally this just means whatever you do to one side, you have to do to the other. So if I'm solving for x minus 6 equals 14, what you do to one side, you have to do to the other. So then we have x minus 6 plus 6 is equal to 14 plus 6. These cancel out, so we have x is equal to 20. So this is just basic how to solve. Right here, this is just how to solve more or less 1 to 2 step equations. So addition, subtraction, multiplication, division properties are all very similar. You're just doing the same thing to both sides. So here, let's see, noting which property of equality is being utilized. So I'm going to add 14.29 on both sides plus 14.29. So I have x is equal to, let's see, 39.29. So this is just the addition property of equality. What I added to one side, I added to the other. Alright, so here, to get y by itself, I'm going to multiply by the inverse. So I'm going to do multiply by 3 over 2 on both sides. By multiplying by 3 over 2, I cancel out the 3's, I cancel out the 2's. So more or less, I'm multiplying by 3 on both sides to get rid of the division by 3, and then I'm going to divide by 2 on both sides to get rid of the multiplication. So y is equal to, let's see, can I simplify this at all? Yes. Factor of 2 goes into 2 once, factor of 2 goes into negative 18, negative 9 times. So we have negative 9 times 3 is negative 27. So this is going to be, you can choose whether you want to say multiplication or division property of equality. So the reason I'm saying you can choose, because here I multiplied by the reverse fraction, but honestly, you could have just multiplied by 3 and then divided by 2, you get the same answer. I just did it one step. Alright, and lastly, this is a rough one. So let's distribute out my 3. So plus 12x minus 6 equals 6. So first thing I'm going to do, I'm going to combine like terms. Negative 10x plus 12x is 2x. Minus 6 equals 6. I'm going to add 6 on both sides. 2x is equal to 12. Divide by 2 on both sides. X is equal to 6. Okay, so first, let's see, noting which property of equality. So I did right here, this was the additive property of equality. And then I did the division property of equality. Okay. The properties of equalities are also useful when solving an equation in terms of a certain variable. In the equation below, there's no way to arrive at a value for b, but you can solve for b in terms of a. So how to get b by itself? Subtract a on both sides. Then we have b is equal to 3 minus a. And then I can use that and plug in. So, solve for b in the following formula. Note the properties for each step. So I'm going to minus 3a on both sides. So that's the subtractive property of equality. Subtractive property of equality. 3b is equal to 6a, let's see, minus 3a. So it's going to be 3b is equal to 3a. Now I will divide both of these by 3. And I get b is equal to a. So of course this is the division. This is the division property of equality. So it's getting really boring to write. Alright, so b is equal to a. Now solve for h in the following formula for a trapezoid. So get h by itself. So we have a is equal to 1/2 h b1 plus b2. First thing I'm going to do is divide by the b1 plus b2 on both sides. So that whole term goes away. b1 plus b2. So I have the area divided by the sum of b1 plus b2 is equal to 1/2 h. So what I can do is just multiply by 2 on both sides. Because this 1/2 secretly is just taking h and dividing by 2. So if I do the opposite operation of division, multiply by 2. So h is equal to 2 times the area divided by the addition of the bases. Cool. Alright, so I need to note the property used. Here I use the division property of equality. Yeah, and the same thing here. I did the multiplication property of equality. Cool, so that assignment will be due the next class. If you have any questions, let me know.